For this lesson, we're going to be looking at another method for solving systems of linear equations, and this time we're going to be doing a solving by substitution. So first, just a little bit of a refresher on what we mean by substitution, and also to get you thinking about what is this actual effect? Why does substitution work? What is it actually accomplishing? So let's start with the equation y equals 2x plus 3. And let's ask ourselves, so what does that mean if I start with y equals 2x plus 3 and then I say I'm going to let x equal -1? And you've done this many times before. If I were to write it out, I would say y is equal to, and instead of 2x plus 3, I would write that as 2 times -1 plus 3. That's a substitution. Okay, so what we're doing is we're saying that the x and the -1 are interchangeable. And so you can see if I make that substitution here, this -1 goes there instead, takes the place of x, and then I could continue and figure out what is y equal to. So putting in a value here for x is going to give me a corresponding value of y. And of course, this is how we actually create our table of values, using this exact process of substitution. If we were to go the other way around and say that y is equal to 7, then my equation y equals 2x plus 3 would actually turn into, I'll just switch the color here, it would turn into 7 equals 2x plus 3. In this case, because I have substituted a 7 in for y, if I continue to move forward, then I'm not going to end up with a y equals, then if I continue forward with this one, I'm going to end up solving for x. So you can see that by making a substitution, if I put in my value for x, I eliminate x from the equation, and all that's left is a value of y. If I substitute for y, I eliminate y from the equation, and all that's left is a value for x. Now here's one. This is where we're getting into some new material. This is where I'm saying, well, instead of saying y equals 7, what if I say y equals x minus 1? So this had y defined in terms of x. And now I'm giving you another definition of y in terms of x. So my original y equals 2x plus 3, I would replace this y with this value x minus 1, because y is equal to x minus 1. And by doing that, I'm going to end up with x minus 1 is equal to 2x plus 3. So by putting in this value of y, now my equation only has values of x, and if I carried on from there, I would end up with x equals something. So this is what we accomplish by doing a substitution. When we do a substitution, whether we substitute in a constant or a number, wherever I make that substitution, I'm basically getting rid of that variable, and I'm going to be left only with the other variable. So each of these underscores, what I have left blank for now, those are actually going to be numeric values. So that's, first of all, that's what we're doing when we do substitution. So let's see, what does that accomplish? Is there a more practical way that I can think about that? So now I've got my graph of the line y equals 2x plus 3. That's this blue line. So what does it mean if I say x equals -1? I can go back to what I started with, which is I could say, well, y equals 2, but instead of x, I'm going to replace it with the value -1 plus 3. And now this time I'm not just going to put a dot, dot, dot. I'll expand it out. 2 times -1 is -2. Plus 3 is equal to 1. So I ended up with y equals 1 as a result of that operation. Now what's the significance of y equals 1? Let's look at x equals -1 from a different perspective. If you recall some other work that we've done in class on graphing, we've talked about that x equals -1. Not only is that like saying the number x or the variable x stands for the number -1, that's also the equation of a vertical line. And we have talked about that idea of equations of vertical and horizontal lines. So x equals -1 is also that line. That is the vertical line x equals -1. But take a look now. The whole point of solving linear systems is to find where two lines intersect. So this might not have been the first thing you thought of. You might not have looked at this and thought, hey, that's a vertical line. But now that I've pointed that out to you, and I've drawn that vertical line here, what kind of result do we get from that? Here is where that vertical line crosses the blue line, and where do they cross? They cross where x equals -1 and y equals +1. That's what we have right here. So that now tells us that we have a point of intersection at -1, +1. That's this point of intersection. Similarly, I'm just going to do this in the reverse order this time. What does y equals 7 stand for? Switch colors here. So what does y equals 7? Well, of course, we could just be saying let the value of y take on the number 7. But another thing we could do is we could say that is a horizontal line. That's a horizontal line where the value y is always equal to 7. I'm going to get another line, and this time I'll do it at y equals 7. So this is the horizontal line, y equals 7. And where does this horizontal line cross our original line, y equals 2x plus 3? It crosses it here. What are the coordinates of that point of crossing? The y coordinate is 7, obviously, and if we slide down here, the x coordinate is 2. So this is the point 2, 7. So when y was equal to 7, I ended up with an x value of 2. And to show you how that plays out, this time I'm going to start with y equals 2x plus 3, that's our original equation, and I'm going to substitute in 7 for y equals 2x plus 3. Now I'm going to move this 3 to the other side, so it becomes -3. 7 minus 3 is equal to 4, is equal to 2x. Then I can divide both sides by 2. And not surprisingly, I end up with x equals 2. 4 divided by 2 is 2. 2x divided by 2 is simply x, which is what I have here. This 2 up here is the same 2. So that's something for you to think about. Not only is this substitution putting in numbers or values, but it also corresponds to some of the work that we've talked about with regards to solving a system of linear equations, the idea of intersecting graphs. These things are interchangeable. And we go to that third example that I started with. So what does it mean if x equals y plus 1? So in this case, I'm going to say that y equals 2x plus 3, but instead of x, I'm going to replace x with y plus 1. So that becomes y equals 2 bracket. Sorry, let me erase that. I was about to make a mess of it. Wherever I have an x, I can replace it with a y plus 1. So wherever I have this x, I can replace it with y plus 1 plus 3. And I start to work through that. Y equals, I multiply this 2 into the bracket, so that becomes 2y, and 2 times 1 is 2, plus 3. I'm just going to bring this 2y, I've already got my numbers over here, so I'm going to bring this 2y over to the other side. Y minus 2y becomes negative y, and 2 plus 3 is equal to 5. And in order to turn this negative y into a positive, I'm going to divide both sides by negative 1. And I end up with y equals negative 5. And this is not complete, but I want you to see that this y equals negative 5, what is this point of intersection? Take a look across there. It occurs where y is equal to negative 5. And it occurs where x is equal to negative 4. So this is the point, negative 4, negative 5. And notice we came up with this, but at no point in time did we ever have an x value of negative 4. We actually substituted we started with the equation of this blue line, and we substituted essentially the equation of this red line into the equation of the blue line, and it told us the y coordinate where those two lines meet. If I wanted to find now, how do I get this negative 4? What if I don't want to draw the graph, or it's not practical to do that? In order to find this x value, now I can sub, and I'm just going to scroll down a little bit here. Now I can sub y equals negative 5 into, and I can sub that into either of my original equations. So if this is equation 1 and this is equation 2, I can sub into either of those, into 1 or 2. So I can sub this value into 1 or 2. If we take a look, 1 is already written really nicely for us to find x, because 1 is x equals y plus 1. So I'm going to use equation number 1, which says x equals y plus 1. And then I'm going to replace x equals, but instead of y, I'm going to replace that with the value negative 5 plus 1. And x equals negative 5 plus 1 is equal to negative 4. Here I have a y value of negative 5. Here I have an x value of negative 4. Those two pieces together give me a point of intersection at x equals negative 4, y equals negative 5, which of course is the exact same point of intersection that we saw in the graph. So graphically or algebraically, we're getting a consistency here. Let's take a look at that again with a little bit more documentation on the steps that we're going to take. So in order to find the solution to a linear system, graphically, we just go ahead and we draw the lines and we figure out where those two lines intersect. If we want to do this without graphing, there can be a number of reasons why we don't graph, but let's not worry about the different reasons for now. Let's just say, okay, what if I want to do this using algebra? So here are the steps that I can take. I isolate the variable in one of the equations. It can be x or y, or whatever variable, whatever the other variables might be. There's nothing saying your equations will always be equations in x or y. We just start that way for consistency. Substitute the isolated variable into the other equation. That's essentially saying I'm going to take one equation and I'm going to put it into the other equation. And by mixing them up that way, what comes out the other end is going to start to give me information about, and that's what happens here, solve for the single variable. That's going to give me information about the point of intersection. So that's essentially going to give me 1/2 of the point of intersection. So by solving for the single variable, I get 1/2 of the point of intersection. And then I take this answer and I sub it into the isolated equation from step 1 to find the other half. So this will give me the second half. And so from those two things, I now have the full point of intersection. And I've found the point of intersection without actually doing it visually or graphically. I've done it using just algebra. So let's put that into practice. I've been asked to solve y equals 3x minus 2, and even though this is not written in the form y equals mx plus b, this is still a linear relationship. This could still be considered to be, you could still graph this. Now I've done you the favor here. This one is already written for you very nicely. This one already has x isolated. So x is already isolated here. And so we're going to start with equation 1 and equation 2. And we are going to sub equation 2 into equation 1. So y equals 3, but instead of the x from equation 1, I'm going to replace that with the entire contents of equation 2, y minus 2. And that's going to be subtract 2 on the end. So what I've done is I've taken this y minus 2 and essentially I have put it in here where x used to be. Now I expand this out. 3 times y is 3y. 3 times negative 2 is negative 6 minus 2. I'm going to bring my 3y over to the other side, so that becomes y minus 3y equals negative 6 minus 2 is negative 8. Negative 2y equals negative 8. Divide both sides by negative 2. And I end up with y equals 4. So that's the first part of my point of intersection. That's the first part of my solution. Now that I have y equals 4, I want to find x. Take a look at our equations. Which of these two equations is well positioned to help us find the variable x? It's this one. This one is already written, equation 2 is already written as x equals y minus 2. So now I basically take this value, and instead of x equals y minus 2, I'm going to write this as x equals 4 minus 2. So what I did, just color coded here, is I took this value and I substituted y equals 4 into equation 2. And if I were to document that, I would say sub y equals 4 into equation 2. And then I would say, okay, well, here's what equation 2 looks like. And now I go ahead and do my substitution. And I end up with x equals, well, 4 minus 2 is 2. So my point of intersection is 2, 4. That's also the same thing, or I could say my solution is 2, 4. Both of those are valid responses here. Here is that same question represented graphically. The line y equals 3x minus 2 is this blue line. The line x equals y minus 2 is this red line. And you can see the point of intersection between the two of them is at 2, 4. x equals 2, y equals 4, which is, right, the solution we came up with algebraically. For this one, we're being asked to solve 2y equals x plus 5 and x minus 4y equals 0. So the question becomes, which variable should I isolate? Do I want to isolate in equation number, let's call this equation 1, and equation number 2? Do I want to isolate x or y in equation 1? Do I want to isolate x or y in equation 2? Where should I start? Now, if you think of the things that you would do to isolate, let's take a look at equation number 1. If I wanted to isolate x, would that work out? Yeah, that's not too bad. Equation number 1, I could take 2y equals x plus 5. I could subtract 5 from both sides and I end up with 2y minus 5 equals x. So isolating for x seems like a pretty good idea there. I could also have taken equation number 1 and I've got 2y equals x plus 5 and then isolate for y. So how do I isolate for y here? I divide both sides by 2. Y equals x over 2 plus 5 over 2. And it's not to say that we can't do this, but is that really a good idea? Now we're dealing with fractions. Why would we want to deal with fractions unless we absolutely had to? So this one is a good idea. This one is probably a bad idea, or at least it's a poor idea. Let's take a look at equation number 2. X minus 4y equals 0. If I isolate for x, this just becomes x equals positive 4y. Yeah, that seems like a good idea. Whereas if I started with equation number 2 and I wrote x minus 4y equals 0, negative 4y equals negative x, divide both sides by negative 4, I end up with y equals negative x over negative 4, which is the same as y equals x over 4. Again, probably a poor idea. So we could isolate equation 1 for x or equation 2 for x. Seems like that's the way for us to go here. And choosing between these two, it really looks, not only is this one a good idea, but I think we could make the argument that this one is our best idea right here. It's not just a good idea, this one is our best idea. This is definitely the simplest thing for us to work with, x equals 4y. Now, if you don't see that when you're doing this work, that's no big deal. This one was still a good idea. If possible, we really want to avoid the bad ideas. So let's say I'm not going to do this one, I'm not going to do this one, and because I decided this was the best idea, I'm going to use this one. So now let's go ahead and solve this. And I think for me to solve this, I think it's going to be cleaner if I just kind of rewind the clock here and start this way, which is I'm going to say equation number 2, which was x minus 4y equals 0, that becomes x equals 4y. We've changed equation 2 into a new equation, so I'm actually going to relabel this equation number 3. I know it still stands for the same thing, but we want to be referring to the different forms of our equations as well. Now I'm going to sub 3 into 1. And what is that going to look like? Well, equation 1 was 2y equals x plus 5. And I'm going to replace that x with 4y. So then I get 2y equals, but instead of x, I make the substitution of 4y plus 5. I want the y's together, so I'm going to do something different this time. I'm going to actually keep my y's positive on the right side. So I bring 2y over, it becomes negative 2y. 4y minus 2y is 2y. Positive 5 goes to the left side and becomes negative 5. Divide both sides by 2. and I end up with negative 5 over 2 is equal to y. Now, I was talking about fractions before. Now we can't get away from it. We've got a fraction and we have to deal with that. How do I find my value for x? Now that I've got this answer, I'm going to sub y equals negative 5 over 2 into which equation is well positioned to receive this. You could substitute this into equation 1 or 2 or 3 and it would give you the correct answer. But which one is the easiest one to work with? I would say that 3 is the easiest one to work with. It's already written x equals. So equation number 3 said x equals 4y. So x is equal to 4, and we're going to make our substitution now. Negative 5 over 2. Don't forget that 4 is the same as 4 over 1. So when we go ahead and do our multiplication, x equals, you might want to, you could do this in your head, 4 over 1 times negative 5 over 2. I recognize that 2 goes into 2 once, and 2 goes into 4 twice. And then we end up with 2 times negative 5 over 1 times 1, which is simply negative 10. Therefore, our solution is, the x-coordinate of our solution is negative 10, and the y-coordinate of our solution is negative 5 over 2. Okay, and that's it for our examples on solving by substitution. If you wanted to make sure that the work that you had done here was correct, you could always perform a formal check in order to verify this solution. And if you have the time to do that, that's a really good idea. Some questions are going to ask you to do that whether you like it or not.